Here we're asked to set up an integral that gives the arc length and to use a calculator or computer to evaluate the integral. The function that we have is y equals x e to the negative x, and the interval is x going from 0 to 2. Now recall that the arc length formula is L equals the integral from a to b of the square root of 1 plus y prime the quantity squared dx. And here I'm using y prime because our function is given as y as a function of x. Now what I'd like for you to do is go ahead and pause the video. I know we haven't even seen an example, but I'd like you to pause the video and set up the integral using the formula. Using the product rule, y prime is equal to e to the negative x minus x e to the negative x. And I went ahead and factored out the e to the negative x, so I have e to the negative x times the quantity of 1 minus x. Y prime squared then is e to the negative 2x times the quantity of 1 minus x squared. Adding 1 because of the 1 plus in the formula yields us L is equal to the integral from 0 to 2 of the square root of 1 plus e to the negative 2x times 1 minus x, the quantity squared, dx. And then we were asked to use a computer or calculator to compute the result. And so I've gone to wolframalpha.com, and as you can see, I've entered it in as integrate the square root of 1 plus e to the negative 2x times 1 minus x, the quantity squared, from 0 to 2. You can just type it in like that. And make sure that all the parentheses are straightened out the way they need to be. And after it's done its work, it says, hey, this is the integral I think you meant, and here is the answer. And so we have approximately 2.10239. So we'll write that down as our answer. This is approximately 2.10239. And we were asked to set up the integral, so I'm going to go ahead and box that as part of the answer as well. Fix that just a little bit. Next, we're going to evaluate an integral by hand. Find the exact length of the curve. 36y squared equals x squared minus 4 the quantity cubed. X is going to go from 2 to 3. Y is greater than or equal to 0. We don't have y as a function of x here, and so it's actually up to us as to whether we want to solve for y or solve for x. But the interval we are given is in terms of x. X is going from 2 to 3. And so that tells me that I'm going to use dx as my integral, which means in my integral, which means I'm going to solve the equation for y. First thing I'll do is square root both sides. So we get 6y is equal to x squared minus 4, the quantity to the 3/2 power. I don't need the plus or minus because we were told that y is greater than or equal to 0. So then y is going to equal 1/6 times the quantity of x squared minus 4 to the 3/2 power. At this point, what I would like for you to do is fill out the formula for arc length. So go ahead and take the derivative and put this into that formula. Pause the video here. I'm going to take a moment to make sure you're on the right track here. The derivative is going to be using the power rule and the chain rule. So we've got 3/2 times 1/6. That'll be 1/4. X squared minus 4 to the 1/2 power. And then here we see the chain rule coming in. The derivative of the inside function is 2x, and giving us a result for the derivative of 1/2 x times the quantity of the square root of x squared minus 4. Y prime squared is then going to be 1/4 x squared times the quantity of x squared minus 4. Adding 1 to that gives us 1 plus 1/4 x to the 4th minus x squared by distributing. Now something nice is going to happen here. Our arc length is then going to be the integral, we were told x goes from 2 to 3, of the square root of 1/4 x to the 4th minus x squared plus 1. I need to trim, all trimmed, dx. And the one of the techniques that we use here is to recognize the radicand as the square of a binomial. So thinking of things in those terms, if you haven't finished the problem, go ahead and do so now, please. All right, so it turns out the integrand is 1/2 x squared minus 1 the quantity squared inside of a square root. The square root does away with the exterior squared. Another way to go would have been to factor out the 1/4 within the radicand, and then you don't have that fraction to deal with. It'll still be a binomial squared. In that case, I would pull the 1/4 out as a factor of 1/2. The result will all be the same. In any case, now we have 1/2 x squared minus 1 is our integrand, so we're going to integrate using the power rule. 1/6 x cubed minus x, evaluated from 2 to 3. Putting 3 in place gives us 9/2 minus 3. Putting 2 in place of x gives us 4/3 minus 2 using the fundamental theorem of calculus part 2. We subtract those two values, and L turns out to be 13/6 for the exact value.